All right, this video is about graphing trig functions when there's a period change. So the period just means it's basically a distance for the traveling a complete cycle, which is basically for sine it's up, down, back to the center. For cosine it's up, down, back up top. So however long it takes for each equation to do that, normally it is 360 degrees, or in radians, it's worth 2 pi. So that's one time around on the unit circle. But sometimes it's different, and we can see it in our equations when it's different. We're going to find the period length is different when there is a number attached to either x, or if this was a theta, or whatever variable that is, that doesn't matter. But whenever there's a number attached to this, is going to indicate there is a period change. So the distance it takes to travel a full cycle is going to be either longer or shorter. So you're going to see a little difference happening when we graph it. So let's first identify these amplitude, period, and vertical shifts. So the amplitude is the number in the front of sine, which is going to be regular 1. Vertical shift is if there's a number on the end here, plus or minus, outside of the parentheses. There isn't one. And I just want to do that for right now and show you the regular sine graph. So normally the distance is 360, 180 is right here, 90, 270. So just going to graph a regular sine curve, which you're always going to start by doing if it said sine here. If it said cosine, you'd graph a cosine curve. So it starts at 0, up 1, 0, negative 1, 0. All right, that's all great. So now we need to find what the new period length is for this equation, because normally there's only an x in here. Now it says 2x. So what we're going to take all the stuff right here, the stuff with the 2x. Later there'll be more. There could be more things in there. We're going to take the stuff with the variable, and we're going to set that number equal to the typical period length of sine or cosine, which is worth 360 degrees. So I'm going to take 2x equals 360 degrees, and I'm going to solve this for x. This is going to tell us the new distance it takes to travel one cycle. So it's going to take 180 degrees to travel one full cycle up, down, and back to the middle again. So I'm going to relabel my x-axis here. So it's starting at 0 still, but it's going to end at 180. So in the middle is 90. We're basically working on this first half of the equation instead, or the first half of the graph instead of the whole thing all the way to 360. So in between here, actually let me switch to a different color. That might be easier to tell the difference than purple and black. So here's 180, here's 0, and 90 is in the middle. What's also half of that? That's going to be 45. And it's kind of hard to see there. And then half of that, or in between those two, this is symmetrical. So from 0 to 45 is a distance of 45. 45 to 90 is 45. 90 to blank is also 45. That's going to be 135. Ooh, that looks kind of gross now. And then also between here and here is 95. So everything is symmetrical. That's why we're evenly spacing out these values. So we're going to do a regular sine curve and said it's just going to be all squished into this half of the graph. So still at 0, and then it'll go up at 1, and then at 0, then it's down at negative 1, and then 0. So this is all black now. Good job. But from here down, that weird thing is sine of 2x, which was the original equation. So let me write in here, this period is 180 degrees. So basically, if I were to go this whole length of 360 degrees, think how many of these orange ones would fit inside that distance. There would be this one, and then it would repeat itself again. So there would be a total of 2. That's why this number is here. That tells us how many. So there's 2 regular cycles in 360 degrees. So that's why there's only 1 cycle in 180 degrees. And we're only going to draw 1 cycle of this. So in the future, I just wanted to show you why that's changing. So we only want to show 1 cycle, so that's why we stop here. So what we're going to do in the future, instead of writing the original x coordinates out, we're just going to change those right away. So I'm going to show you that on another question. Let me try to erase this part. And let's go on to number 11. show you that over here, which is cosine of 1/3 x. Okay, so period is the distance that it takes to travel. So let's identify everything. First, amplitude is not changing, that's a 1. The period, we'll come back to that. Vertical shift, there isn't one. So the period, we're going to set this stuff with the x equal to the normal period length for cosine graph, which is 360 degrees if we're in degrees. If we were in radians, it would be 2 pi. And I want to solve this for x, so I'm going to times 3 times 3. So I just get x on the left. 360 times 3 is 1,080 degrees. So that's how long it's going to take to do one up and down cycle, or in this case it's cosine, so up, down, and then back up again. So 180 degrees is our period. Oops, 1,080. I knew I was saying something wrong. Okay, so that's how we found it. So I'm going to draw an axis here. I'm going to start at 0. But instead of ending it at 360 degrees, I'm going to end it at 1,080. Because if I didn't, right, if this was normally 360, I'd have to go on 3 times as long to get to this value on the end. Okay, it would be really, really stretched out. This is 1,080. 360 is somewhere inside here. So let's figure out where those are. Halfway between 0 and 1,080 is 540. In between these two is 270, and so I want equal distance on this side as well, so 540 plus 270 is this number. Right, that's how we're going to get that, and that's going to be 810. Okay, so we got an equal distance between all of them. So now I'm not going to really draw the original graph anymore. We're taking care of that by renumbering the x values. So cosine, right, between 1 and -1, there's no amplitude change. So normally starts up at 1, 0, then it's down, 0, back up. And I'm going to connect those. So if you were to graph this in the regular 360 degree ending spot here, we would only see about 1/3 of this graph. So right, 360 is kind of in between here. 360 is in between here. So we'd only see about this much of the graph. But now, instead of making my table or my graph end here at 360 and just keep going like forever and ever, that would take up a whole lot of room. So we just shrunk it down. So the graph doesn't really look different. However, if you were to graph only between 0 and 360, it would kind of stop, right about here. So that's why we're changing this number on the end. So you can go ahead and start doing that and writing the distance it takes. We're starting at 0 right now. So we had to go from 0 and do this distance. That's why this end number is 1,080. So that's with a period change.